As you see in our seventh example of derivative of inverse trig functions, we have quite a problem. F of x is equal to the arcsine of x plus x times the square root of 1 minus x squared. Find f prime of x. So you see that we're going to have to deal with a derivative of an inverse trig function. We're going to have to deal with the fact that we have the derivative of the sum of two functions, and one of these terms is in fact a product of two functions. So we've got quite a bit on our hands here. Before we get into the middle of this problem, I would like to emphasize something I'm afraid that I haven't made enough of a deal out of so far, is that when we found the derivative of the inverse trig functions, for instance inverse sine or arcsine as it's known as well, we actually found the derivative in terms of the chain rule. That is, assuming that the argument of the inverse trig function was u, not exactly x, meaning some expression in x or some function of x. So that's the reason we end up having to use the derivative of u as we calculate that derivative, because that's the chain rule. Now, if our argument is simply x, the standard arcsine of x, or inverse sine of x, or inverse tangent of x, so on, that is, if we're taking the derivative of this with respect to x, our argument being x, then we just simply have 1 over the square root of 1 minus x squared, and I suppose we could say times the derivative of x, but that's just 1. So this is the standard form. We're not using the chain rule here. Okay, well, let's begin our problem. Now, I've actually done all of the work in advance, and I'm going to reveal a little bit of the work at a time. And I would encourage you that if I'm going too fast, that you can always pause the video, you can rewind, you can get all the notes that you need to get here. So we first think of this as the sum of two functions, and so the derivative of y with respect to x, or I suppose I should have said f prime of x here. That's really what we're calculating, isn't it? F prime of x, okay, is the derivative, the sum of the derivatives. So it's the derivative of the arcsine of x plus the derivative of the product x times square root of 1 minus x squared. Now, the derivative of arcsine of x we just discussed above. That is, that's just 1 over the square root of 1 minus x squared. So all of this just simplifies to 1 over the square root of 1 minus x squared. But when we look at this second derivative here, we have to recognize that we have a product of two functions. And so to find this derivative, we're using the product rule. And so it's going to be a little more complicated. And remember, the product rule says take the first function, which in this case is x, and multiply it with the derivative of the second function. So here we have the derivative of the square root of 1 minus x squared. And then add to that the product of the second function, there's the second function, times the derivative of the first. And of course we could have done that in our head, but I prefer that we write it down so that we know exactly what we were doing as we work through the problem. So let's see what we can accomplish now. Of course, this first term is not changing. And notice here, of course, here's my x still. What I'm going to do before I find the derivative of this square root is I'm going to put it into a form that's a little easier for me to calculate derivatives of. That is, I'm going to change the square root symbol to the exponent 1/2. And so I have the derivative of 1 minus x squared to the power 1/2. And of course here I'm just calculating the derivative of x to be 1, and that's what I've written in this position. Now let's see a little bit more of what we've got here. So we still have this first term, 1 over root 1 minus x squared. We still have this x. We're going to calculate this derivative. So using the chain rule in the form of the general power rule, we take the exponent 1/2, we multiply it in front, we reduce the exponent on the argument 1 minus x squared, we reduce that exponent by 1. So we say 1/2 minus 1, and that's, of course, that's where that negative 1/2 came from. This came from 1/2 minus 1. That's where we get that exponent. Okay? But then we cannot forget that we have to multiply, that we were using the chain rule. So we've got to multiply with the derivative of 1 minus x squared. And the derivative of 1 minus x squared is negative 2x. So all of this, everything in here, is the derivative of the square root of 1 minus x squared. And then, of course, we just have plus the square root of 1 minus x squared here at the end. Okay, well, in this middle term, we can do quite a bit of simplification. Of course, the beginning of the expression is not changing. In the end of the expression, there's nothing to simplify. But this middle term, there's quite a bit to simplify. And notice we have a positive times a positive times a positive times a negative. And so that's where this negative comes from for that middle term. And notice also that we have a 1/2 times a 2, and so we end up without that fraction. That ends up being 1, and we also have an x times an x, which is x squared. So x times 1/2 times negative 2x becomes negative x squared. Now, of course, 1 minus x squared to a power that's negative 1/2 is the same as 1 over 1 minus x squared to the power positive 1/2. And of course, a 1/2 power means square root. So this whole piece ends up as 1 over the square root of 1 minus x squared. And then we look a little further. Of course, here we can multiply the x squared with this fraction, so it ends up with x squared in the numerator. Probably we could have seen through that real quickly, but I wanted to go ahead and do that. And now look, we have two fractions with the same denominator. So we can actually perform the subtraction on those two fractions. And we just take the numerator of the first and subtract the numerator of the second, and so we end up with 1 minus x squared over the square root of 1 minus x squared plus the square root of 1 minus x squared. Now, of course, one of the dilemmas in calculus always is, how do I leave my answer? Do I add these two pieces together? Do I simplify anything? What do I normally do? Well, I normally look in the back of the book at this point and see my answer. And of course, this isn't the answer that's in the back of the book. I would like to, there are a couple of things that we could do. We could get a common denominator with these two and then add two fractions together. But I'm taking a little different path here. I'm taking this fraction, and for illustration purposes, I'm writing 1 minus x squared as 1 minus x squared to the power 1, because I'm noticing in the denominator I have 1 minus x squared to a power 1/2. So I have the same factor with an exponent of 1 in the numerator, exponent 1/2 in the denominator. And of course, in that case, I can do the calculation of just subtracting those two exponents. So if I take the top exponent, subtract the bottom exponent of 1/2, then I end up with an exponent of 1/2, and that's what I've written here. So I've simplified that first term to just 1 minus x squared to the power 1/2. And we all know what that means. That means square root. So that first term is really just the square root of 1 minus x squared. And the second term is also the square root of 1 minus x squared. And so adding the two coefficients, 1 and 1, I have 2 times the square root of 1 minus x squared. So we had to do several things in this problem. Not only know how to take the derivative of the arc sine function, but also how to deal with a sum of functions and the derivative of a product of functions, and then of course a significant amount of algebra, which is not unusual. Well, that concludes for now our discussion of derivatives of inverse trig functions.